Okay, so this problem we're going to be working on 4-57. We have a recipe calls for 2 2/3 cups of flour to make 2 regular batches of cookies. Shallow needs to make multiple batches of cookies. So we're first being asked to represent this situation within the equation. So this is the second problem you guys are going to be asked to actually create an equation and relate the idea of proportional relationships. So I think there's two different ways to look at it. I think the best way for you guys to look at this point is to relate it to a table. So if we actually make a table with this information, let's look at the two variables we have. We have 2 2/3 cups of flour, and we have 2 regular batches of cookies. Okay, so those are the two variables. Those are the two things that are going to be changing. Let's create a table from this information. So let's see. So on one side of the table we'll have batches of cookies, and on the other side we'll have the cups of flour. Okay, so we know for 2 2/3 cups of flour we make 2 batches of cookies. So 2 batches of cookies, it will take 2 2/3 cups of flour. 2 2/3. So let's look at some of the other information that we have. If we have two batches of cookies making 2 2/3 cups of flour, using 2 2/3 cups of flour, hopefully it makes sense by now that if we have the amount of cookies we make, so instead of making 2 batches we make 1 batch, we have the amount of flour we use. So instead of 2 2/3 cups of flour, we'll only need 1 1/3. Okay, so hopefully you guys notice now that, okay, if we increase the batches of cookies by 1 batch, we increase the cups of flour by 1 1/3 cups. Okay, so looking the other way now, let's say that we decrease the batches of cookies again. Instead of making 1 batch of cookies, let's just go ahead and assume that Shallow does not need to make any cookies at all. So Shallow is going to make 0 cups or 0 batches of cookies. That hopefully it makes sense by now that we need 0 cups of flour. In other words, we decrease the cups needed for 1 batch by 1 1/3. So how does this help us write an equation? Because right now on Friday you guys are really stuck with writing equations from this. How I explained it briefly in class is that we are going to go ahead and use the let statements. So I have this table on the side for you guys to see, but let's go ahead and use the let statements, and let's go ahead and identify our variables. I can't remember what we used in class. You guys came with a variable, so I'm just going to go ahead and make up new variables. I'm going to go ahead and say let x represent the batches of cookies, okay, and we're going to go ahead and let y represent the cups of flour needed, so cups of flour. Okay, we could look at the initial information they gave us, which means that we need 2 2/3 cups of flour for 2 batches of cookies. But if we look at our table, we simplified some of the information. So instead of making 2 batches, we'll go ahead and assume we only need to make 1 batch, and we'll make an equation relating the 1 batches. So let's see. So if I need to figure out how much flour we need, and that's represented by the y. We'll go ahead and say y equals, or the cups of flour is going to equal how many batches of cookies we make. For the batches of cookies, we're going to represent that with x, and we're going to multiply the x by how much flour is needed for each batch. So let me go and highlight this. So we only need 1 1/3 cups of flour for every batch of cookies. Okay, so we'll multiply the x, or the batches of cookies, by 1 1/3. Okay, so this would be our equation. Y, or the cups of flour needed, equals 1 1/3 times x. Okay, so Now we have to figure out what the constant proportionality is, and that's the new vocabulary word that you guys had to identify. Let me go and flip to the textbook really quickly. And if you guys notice right here, proportional relationship equations are of the form y equals kx, where k is a constant proportionality. When we read the introduction in class, I kind of told you guys to ignore it because it really doesn't make sense to you guys at this point. I told you guys to just consider unit rates, but we're going to go and use this equation, y equals kx, to answer this next question. So I'm just going to copy that over really quickly. Let's see. So what is the constant proportionality? Let's go and write that equation out. Y equals kx. Okay. And they told us that k is the constant proportionality. In other words, k represents that multiplier we talked about, or the unit rate that we talked about. So basically, if we look at the equation we came up with earlier, y equals 1 1/3 times x, x is represented by x, y is y, and k is the 1 1/3. So the constant proportionality is 1 1/3 for this equation. Okay. How can we identify in an equation? So there's a couple ways, but I think as of right now, if you guys could tell me that really the constant proportionality is the number multiplying the x, it's the coefficient of the variable. Okay, so we can identify the constant of proportionality because it's the coefficient of the variable. Okay, I think as of right now, if you guys can identify that, I will be very satisfied with that. Okay. Finally, how can we use an equation to determine if a relationship is proportional? And this is really difficult for you guys. But if you guys remember some of the previous examples we used, such as the example with Gustavo and how his situation was not proportional, I don't like how the textbook kind of had you guys jump to this conclusion when they didn't really help you guys figure this out. So as of right now, if you guys could go ahead, if you guys are able to tell me that a relationship is proportional if it does not add or subtract, I'll be satisfied with that. So let's go ahead and respond to this. A relationship equation will not be proportional if there is addition or subtraction. Okay, we'll continue reviewing this. We're going to spend Monday's lesson reviewing this. So if you guys are not experts or mastered at this content at this time, it's okay. We'll look through this again when we look through the 8th grade book next month as well. So hopefully this gives you guys a better idea. You guys did seem to be a little bit lost when we talked about the equation, but you guys did a great job with the graphs and the table. So hopefully this helps you guys a bit, and if you guys are still not experts at it, don't worry, we'll get there.